Welcome back. This is section 4.5, day 1 still. We just got done solving where like bases were very friendly, easy to find, easy to use. Well, what happens when you can't make like bases? We're going to have to introduce logs and natural logs, preferably natural logs, but we're going to use them to both sides. They are a mathematical function, so we can take the natural log or the common log of both sides. The reason we use those two, again, makes it calculator friendly. We're going to first find examples that have an exact answer, and then I'm going to let you play with your calculator to come up with the approximate answer. If you need to, there is a note guide posted on Focus website under the resources if you want some step-by-step help. So take a look at example 4. Notice it's a base 10. That probably means we're going to take the log of both sides. So when I do that, we now have the opportunity to use some properties of logs. This is the power law, which allows me to move that 2x out in front, and it's now a product. Now sections 4.1 to 4.4 gave us tons of properties, and right now you're going to start seeing them. Here we have log base 10 of 10. The argument and base are the same. That turns into a 1. Now we have a nice friendly log equation. We want to get our variable by itself like any equation, so all I'm going to do is take and divide both sides by 2, and that represents my exact answer, also known as calculator friendly. And if you take your calculator and you type it in, take log of 4 and divide that by 2, we get our approximate answer of 0.3010 if I round to 4 places. So round 1, 2 answers. Best answer is the top one. That's what we'll be looking for, and then change it to an approximate. Our next example doesn't have a base 10, so this time we're going to see me use natural logs. If I don't have a base 10, definitely going to be natural logs on both sides. Again, the power law. 2x minus 1 comes out in front of natural log of 3. At this point, you have two options. You notice we could distribute the natural log of 3 into those parentheses. Option 2, we could divide out the natural log of 3. I think dividing the natural log of 3 is a little bit friendlier. You'll see less logs in the problem, which will make you a little bit happier. So I'm going to divide both sides by that natural log of 3. Now back in Algebra 1 you solved literal equations where you just simply move things. You never did really any math. Well, right now we're just going to be moving things like furniture in your bedroom. We want to isolate x still, so if you add 1 to both sides, we now have 2x, almost there. Now, instinct says you'll want to divide everything by 2. It's going to make a mess. It will create actually a complex fraction. I'm going to take a different approach to getting that 2 out of there. I'm going to multiply both sides by the reciprocal. Sorry about that extra parenthesis. We get natural log 5 over 2 natural log 3 plus 1/2. That represents our approximate answer. If you take a calculator at this point, we can change that into, sorry, that is our exact answer. I apologize if I said it. And here's what it looks like as an approximation. Both answers are good. Our last example of this style of problem has a little bit more in front of that base. So I'm going to take that 2 and make it go away. We want to isolate our base no matter what it is. Avoid your calculator too. I don't want you to see an 8.5 on that right side right now. Let's keep it as a fraction. We're going to take the natural log of both sides. This is very good for base e because, as you remember, base e is the natural log. Power rule again. We're going to remember that base e is natural log, so natural log of e is just a 1. And then I'm going to take that 3, and I'm going to again use the reciprocal, and now we have our final answer. If you type that into the calculator, final answer as an approximate is 0.7134. That concludes our second part of our homework.